saw machine. I'll bring you around and have a better look. I get quite a lot of questions asked as to why I persist with fossilised machines like this old power hacksaw. It's the only thing I've got with a 200mm or 8-inch cut. And I don't have any oxy-acetylene cylinders, don't have a plasma cutter, so the only option is a 5-inch grinder or a jigsaw, and neither of them are attractive on 8mm plates. So I'll just let this thing wander through, do its thing for another 3 or 4 minutes, and that'll save me a hell of a lot of work. And then we'll clean them up on the shaper. So rather than bore your pants off, I'll bring you back to the next operation's about to start. And this is all the excitement you get as the cut finishes. Soon, I hope. Oh, come on. Dirty, don't disappoint me. It's got a semi-automatic retract, so after the cut is finished it changes the direction of the hydraulic valve to pump the arm back up and turns itself off. The plate's bending now on its last couple of strokes. You've got to appreciate this presents as a piece of 200mm solid material, so it does take a lot of cutting this way. Up on edge of the cut faster, but the noise is horrific. Let's hope it doesn't make a liar out of me. It doesn't get used very often, so sometimes the mechanism's a little bit sad. Yep. This is what should happen. That's finished the job. And something to point out to you guys that are avid users of the Asian-made machines, this was built in about the mid-70s, I suppose. So it's done, what, 45, 50 years of service so far, and other than the electrics, which have been rejuvenated anyway, it's got at least another 50 years left in it. So buy a late model saw. I know bandsaws are a little bit quicker, but you just don't get the machine life you get out of these. And these run unattended. Okay, bring it back when we start Dinasoar number 2. There we are, I pushed it outside away from all the flammables and used some very accurate toolmaker's clamps to hold it while I welded the two together. There's another 3 operations, I think, maybe more, to do to them, might as well do them as a pair. Drill 2 holes at the one time, 2 chamfers, 2 shaper operations to clean up. Just makes life a little bit easier. Yeah, just a little bit of a sideways step. We can't go too long without having a look at some grinder parts. I managed to turn this one over and it was reasonably easy to do and quite safe, thanks to a suggestion from Graham. This is the khaki end, I think, yep, with the adjuster. And I don't think it's as bad as what the lower table was. Time will tell as we scrape it back. It's telling me it wants to be painted down here too, so I can tickle it. Oh well, that's a bit of bad luck. And I got the centre spigot all wrong. I thought it was an annular spigot that took up on the OD of the bit in the middle of the lower table, but it's the other way around. It's a very, very small spigot and removable, but it's no good being able to remove it from underneath because you've got to get it off first to do that. Okay, a little bit here. That is all going to come up. Look, you can see the flaking underneath. Yep, it's in better condition than the top table. It'll still take me a good half a day. I've got to remove all of this grime, then all of that paint, and get it ready, but I'm quite happy. This will come up quite good. G'day there guys. Can't get it all in focus, but I'll try and give you a little bit of a rundown on the shaper for all the young bucks that haven't seen one before. It's a horizontal stroking machine like the radial arm drill, power hacksaw. Don't get your fingers caught in it, it'll tear you to pieces. They're geared down quite slow to use high-speed steel tooling. As a consequence, they have a bag of power and they'll push you to bits. The tool is carried in a tool holder. At the moment I have a shaving or finishing tool in there. The height of the tool is adjusted here and locked as such. The stroke of the shaper is controlled by a little knurled wheel down here with an internal square. You rotate that and it moves the crank position up the slot in the ball gear. The position of the stroke can also be altered along the table. Now that's done with this locking lever here, and you crank that handle and you move the sliding ram on the cranking mechanism down below. Now the main guts of this machine is internally lubricated. That's the gears, the slideways for the ram, and all the inside. But on the outside you've got lots of little oiling points, such as a ball oiler there, the slide here, the pivot for the clapper box. Not using the auto down feed because it's been bustified by someone else. These adjustments here, the auto power feed and the table feed. So I've run around all the ball joints and oiled it up. Next I'll give it a bit of a run to make sure I'm in the right plane and that everything's tight, and then bring you back in and we'll just take a few shaves. I'll get closer and a little bit closer, the camera in a little bit closer so you can see what's happening on the workpiece. Now as the ram does slide backwards and forwards, you have to make sure that the front of the ram clears the top of the workpiece, and you could probably fit a fairy's fart in there today. There's not much clearance. So I'll bring you back when it's about to get exciting. Okay, as the shaper is currently fitted with a finishing tool that is a half round finish at the bottom and very little clearance, and the cutting edge is actually skewed about 15 degrees to the right hand side. I'm only taking a half out depth to cut. Let's hope I don't bugger this up. I have checked the oil sight glass and it did take about 2 minutes for the oil to pump up, which is quite common with these machines when they're left idle for quite some time. Okay, let's see if we can just nudge it to life. And auto feed is on. Take a little while to crank over to where it's been busy. There it goes. It's showing me that the material wasn't cut 100% square, but that's what you get for using old machines with an old man, I suppose. Dead simple to use, dead simple in operation. These were even used for putting draft into dies with an all-angle compound cable. They were very complex machines towards their demise in the 1960s. Such a simple action, but it was just so damn useful. Okay, turn the power feed off. Bring the tool back once I get my direction right. Yep. Apply a bit more cutting compound, and it's one thing that does make these tools last a bit longer, a good bit of gooey goo. I'm a big fan of the sulphurised heavy duty cutting oils. They seem to do a fantastic job. Engage the power feed again. Which works sometimes. There we go. So and we're a clean up. Now even with these old machines, provided I keep my wits about me, I can have the shaper working on what the Poncer calls self-cut or auto-feed, power hacksaw working. I can be using the radial arm drill, the mill or the lathe, and most of the time I'll get away with it. So far I haven't had any big inconvenient crashes, but yes, you can run a few machines at a time, so how long it takes to do the job really is insignificant if you're working 3 or 4 machines at the one time, albeit doing very, very simple jobs, but most job shop work is like that. Well, there you are, one job done. Took all of about, I suppose, 7 or 8 minutes. I'll try and get you down for a, there. You can see the finish is quite acceptable. We haven't lost focus there. And I'll just turn it over, rinse and repeat. And there's the 2 bolster plates squared up and ready to be chamfered. There'll probably be another operation here, I don't know, depends on how I feel for the day. So I'll bring you back then. Bye. G'day guys, back again. Just putting a hole through the middle of the bolster mount plates. It's a 12mm bolt. Goes through it, so I'm putting a 1/2 inch hole for a little bit of running clearance. And I'm just doing this for all the haters from an episode a few videos ago where I was criticised for using wooden parallels. Well, they're not parallels, they're spacers. And for using a radial arm drill. Well, personally, I class a turret mill as just a glorified drill press. It doesn't really have a lot of guts. And 2 things, the timber grips the table really well, and stops me putting holes in the bloody table. Anyway, let's get ahead and make a hole. Very nice machine to use and probably close to my age as well. Let's move on to the next job. I'm just making a quick mock-up to make sure all of this is going to come together. The frames will be narrowed into 150 apart, so they'll be tracking inside of where the wheels will go. And I'm just thinking that the wheels are a little bit close, or the flanges are a little bit close, and if the bogie is tipping on a bit of rough track or going through a set of points, it might just contact. So I'm going to take a little bit off, just chamfer the plates back in about 10mm and back by 25. It won't affect the running of the bearing. That's well and truly inside that area, but it'll just give the wheel a little bit more clearance. The wheels are quite large on the other bogies. They're only 115mm, these are 125, and it brings them up a little bit close to the area of the plate there. I think that'll work out quite well. Still have to figure out the thickness of the spacer from the bolster up to the mount plate. I think I'll just give the bearing 1.5 or 2mm clearance, and that should be good enough. I think it's a goer. 4 hits on the milling machine, and we should do right to go. Bring it back when that's set up. G'day there guys. This is the setup I finished up with to try and mill those chamfers on. I was doing it on the side with a long series end mill, but the cantilever was just too far and it was pretty crappy effort. So I put a large piece of parallel in the vise. Some would call it a strong back, and I don't know how strong its back is, but we're using its front. I can only take about 0.5 millimetre at a time and take it steady, but I'm in no race and we'll eventually get the job done and move over and do the other side. So I'll just give you a look at what it's like taking a bit of light milling here. Might have to put a bit of feed on. Although with the size of my guts I've been putting too much feed on. Without the two auxiliary clamps it really does get a bit of a squawk up. There's not much directly clamping it to the table. But the progress isn't too bad. The lucky part about this is I'm not taking it out to a specific dimension. I'm just taking it out till the chamfers out to a reasonable size out on the side of the block there. I may have to tip it over a little bit. Looks like I'm just a fraction of a degree off, but it doesn't really matter with this job. It's only just to give it a bit of clearance. Okay, I'll bring you back when something else is happening. On to day 2 now. Here's my setup to square up the end of the frames. That part's finished, and the 2 bolster bearer plates still welded together are on the mill table there. You can see the chamfer on the end, this end. They're not all dead equal, but then again they don't have to be. The RHS for the frames, which originally used for a points actuating rod, and you can see the little tab welded on top of the RHS, and also a few more those there whiting out up the other end. I'll just mill those off and turn it back into plain RHS. It's saving the club a few dollars. I've got some spare time and they're not buying new material, so they're probably going to be down $300 or $400 in bill size for this job, which will make them happy. Okay, I'll put the face mill back up and take those tabs off. Back again. In between my jobs on the frames, I'm once or twice a day giving this cylindrical grinder table another squirt of degreaser, and you can see a bit of shiny metal coming through now. I think I'm going to come up with 85 to 90% clean table once again, so I'm very confident the machine will be grinding reasonably true. Okay, back to work for me. And now we're back to number 1 Dinasoar, cutting the material to length. A couple of things about these machines: you've got bigger capacity, and thank God I can hang a bit of steel out of the shed. It allows me to cut it in pairs, so there's less cleaning up afterwards to get them both the size the same way. It's a good old clunker, been with me for years. G'day there guys, back again. I missed a bit of the exciting parts yesterday. The battery ran out and also the audio would have been bloody lousy. We had a hosing down rain. As you can see, I've squared the end off and I used a long series end mill for that, which I'll show you shortly over here. And then I took the top out of them to nestle up under the what will be the upper flange of the PFC I'm using for a buffer beam. And for that I'll use this little indexable end mill. It takes an ADMX insert, which is a rhomboid shaped insert. I'm of two minds with it. It's got a positive rake helix and a positive rake chip breaker, but it's nowhere near sharp. You hear the thumpity thump you expect with a big radius. I think the radius is too large, and I would rather a precision ground insert, especially when they're $15 each. I think they're a little bit on the high side. It does the job admirably, and that's probably done about 30 or 40 minutes cutting time without changing the corner, so it's economic to use. But yeah, it makes a lot of noise when you consider the piece of RHS isn't supported, and it was ringing like a bloody great bell out the front end there. But you get to expect that. Anyway, got the job done. When I get the dimensions for the buffer beams, I'll be able to complete that part of the job. And the sun's coming out now, so I might get to grind all the crap off the body of the frames. Now, that's the long series end mill that I use. It's a special by Sutton, created against a customer request, and then the customer went back on the order. It's 8% cobalt. Cost me a pretty penny, but not as much as he would have paid, I'd hope, as I was a distributor. They've done a good job. It's really well ground. It's as sharp as sin, and even though it had a long stick out, and towards the end I was engaging the full length of the flute, as long as you weren't too vicious with it, did a terrific job. Now that one has also done a hell of a lot of work, and it's showing no zones of wear, so I'm quite pleased with the dollars, and I can resharpen them if I have to. That tool is worth resharpening. Okay, when I get a bit more to do, I'll bring you back and show you some more. Bye for now. Back again. Here's a bit more done that you might want to see. The buffer beams have been cut to size and squared up in the mill. These are the riding plates that go up on top of the bolsters. These are the tow bar pockets and the plates that they get welded to, and they will be mounted to the buffer beam. As well as that, I've cut the main frames to length and prepped the ends to socket in behind the buffer beams. But now comes the big question. The rear coupling, is it by drag bar or is it by knuckle bar coupling? This is what happens when there's no drawings. You just don't know what the bloody hell you have to do. These plates have also had a about 15-degree chamfer put on the outside so that the wheel flanges don't interfere with it as the bogies twist underneath the car. So that's with the frames and sanding them back, about 4 hours work. Not bad progress so far, especially as the material was mostly scrap. Bring you back when something else happens. G'day again, day 4 of what's going on in the shed. I have to leave the loco frames for a day or so while I try and find out what they want for the rear coupler. I think it's going to be a knuckle type coupler, and I need to know what the standard socket is. But in the meantime, I watched a Tom Lipton Ox Tool video yesterday cleaning up an old machine. Lucky fella's got a Kearney and Trecker H1 horizontal mill, which I would like as well. A bit like DD's round and sharp with the horizontal and vertical head. I wouldn't mind one, but still, we all have our druthers. But my cleaning operations, I've been touting degreaser and caustic solutions, and Tom swears by a solution based on vinegar, acetic acid. Why the hell he kills it with baking soda, I don't know, but we'll see what happens. Anyway, I've got the table soaking in the caustic degreaser. I've just scraped much of that off and wiped it, and I've put down some toweling, and together we'll squirt a bit of vinegar on and come back tomorrow and see what the old rusty bits are like. So I'll swoop you down, you can have a look. G'day there, guys. See you. Yeah, you can see there's plenty of yuck left on the table around it. It's starting to get close to metal, but just not good enough to maintain dimensions on the table, in my humble opinion. And that's it. Yeah. Now, I've used citric acid in the past to pickle some mill scale of steel, and it worked the treat. But then I left it for the rest of the week, and it turned into this black, bloody Vegemite shit that was, it's like old gummy enamel paint. It was an absolute turd to get off. That's a good description, yeah. It was like poo sticking to a blanket. And yes, I am giving it an extraordinary dose because I want to see this work. And a little bit around here where there's no paper. That's an almost clean part. Same for up the end there. We'll see what it's all like tomorrow. Okay, bye for now. Please like and subscribe if you haven't already, and send me any messages you want down the bottom of the page. See you later.